right, this is the last section of 2.2a. So what it is, I kind of broke up the notes a little bit, and I'm solving it slightly different. In your book, I just split up when I do the notes. So we're going to talk about systems involving three equations, which has three variables. And so that what that means, if you were in my class, talked about the corner of the room, you have an x, y, and z where everything meets in the corner. So this is actually a three-dimensional thing. Obviously, if we had a computer, we could do this. You can't do this in your graphing calculator because that doesn't graph 3D. So we do it by using elimination and substitution, mostly elimination from before. So I'm going to write the steps, and then I'm going to use example number 1 up here and go along with each part as I go. So the first part you're going to do is that you have to pair two equations and eliminate a variable. Let me write that again. So pair two equations and eliminate a variable. Let's say one variable. Doesn't matter which one you choose, either one. So what I'm going to do is I'm going to number these equations 1, 2, and 3. So when I reference that, it'll help me to remember which one I used and don't get confused. Okay, so I'm going to eliminate, I'm going to use equation 1 and let's do 2 and 3. And so what I want to eliminate when I do this is I'm going to eliminate my y's. You could have chosen another one to eliminate. Doesn't matter, but I'm going to eliminate y's. And what I'm seeing here is I see that I have, these are going to be opposite, and that's why I chose to do that way. Nice and easy, opposite coefficients, and hopefully it'll make a nice, clean equation. So what I'm going to do, 2x minus y plus z equals 8. And I have 3x plus y minus 2z equals -1. So it says when we're eliminating, we add the two together. And I want to eliminate my y's. So that's what should happen. So I have 5x. That goes away. Z minus 2z is a -z. And then 8 minus 1 is a 7. Okay. Now step 2. We are going to pair the unused equation with one of the other equations. Doesn't matter which one. And eliminate the same variable as you did in step 1. Okay. Now when you get done with this, okay, when completed, when step 1 and 2 are completed, you will have a new two-step, I keep saying step. So when step 1 and 2 are completed, you will have a new two-variable system. Okay, so I used equation 2 and 3. So this time I have to use 1. So equation 1 up here has, let's see, I'll write that down here. So I'm going to use equation 1. I'll use equation 1, and I have to eliminate, I have no choice. I have to eliminate y, because I eliminated y up here in step 1. So if I want to eliminate the y, I'm going to just go ahead and do 1 and 2, only because I can see when I write these out. I'll show you. I'll write them down here. So equation 1 and 2. So equation 1, I have x plus 3y plus 3z equals 5. And equation 2 is 2x minus y plus z equals 8. Make sure I write my equations down right. So when I have, and the reason I chose that one, because right here I can see that the y's have to cancel. They're already opposites. The only thing is I need to create equation 2 to have a negative 3. Okay, so I noticed that I accidentally wrote a 3 here when it should be a 2. Apologize about that. One thing, take note, be very, very careful. Go slow. So in order to make that opposite with the y in the first equation, I'm going to multiply this bottom equation by 3. And I'm just going to put it this direction. 6x minus 3y plus 3z equals 24. And I'm just going to move this over here. X plus 3y plus 2z equals 5. And I'm going to add that. So this gives me a 7x, 3y minus 3y is gone, 2 plus 3 is 5, equals 29. Now, at this point, I've created my new system with 2 variables, okay? So I've got this one up here, and I have this one down here. So I'm going to take those 2, and I'm going to write them in part number 3, okay? Because part number 3, or step number 3, I should say, tells us that we have to do some more with that new system. So I'm going to go ahead and write the system down here. Doesn't matter which one goes first. 7. Oops. $7x plus 5z equals 29. My other one was from above, 5x from step number 1, z equals 7. So there's my new system, okay? So now that you have the new system, what you're going to do is solve this new 2-variable system for both variables. It doesn't matter which way you do, substitution or elimination. It is your choice. I'm going to eliminate. I'm going to actually multiply this. I'm going to eliminate my z's, so I always want to say what I'm eliminating. So I'm going to eliminate z's. When I do that, that means I have to multiply this bottom equation by a 5 to have it the opposite of this one. Because this is a positive 5, I need a 5 here. So I'm going to write that equation down below. So 5 times 5x is 25x. 5 times this z is a negative 5z. And then 5 times 7 is, 35. Okay, I'm just going to take the top equation from here and bring it down here. So 7x plus 5z equals 29. Just a reminder, if you're watching, when you watch my videos, if you notice that I only put z's and 7s have lines through them, and nothing else does. So if my 2's look like a z, it's actually not a z if it doesn't have a line to it. So I always choose to eliminate. I find that elimination to me is much easier to do. I think also too, I don't like to have to move everything back and forth. So I just like to get rid of something. All right, so when I add up my like terms, I get 32x equals 64. Divide both sides by 32, and x equals 2. Now, using one of those two equations from here up above, you're going to solve for the other variable. So now we're going to solve for z. We know x is 2. So I'll just choose the top one. Doesn't matter. So 7x plus 5z equals 29. So in place of an x, I am putting, oops, that's not what I meant to do. I am putting 2, apologize. And then I'm going to solve for z. 7 times 2 is 14. Subtract 14 from both sides. 5z equals, so 29 minus 14 is 15. I divide by 5, divide by 5. So I have z equals 3. So I have this value and this value so far. All right, last step. Okay, we're going to substitute two solutions from step number 3 into any one of the original equations. Put word 1 there. Any one of the original equations to solve for the third variable. Doesn't matter which one you choose, 1, 2, or 3 from the example above. So I'm actually going to choose number 1, just because. So my equation for number 1, so I chose equation 1, and I have x plus 3y plus 2z's equal 5. And in place of x, I'm going to do a 2 from here. In place of z, I'm going to put a 3. So x is 2. X is 2. Let's try that again. Plus 3y. And then z is 3. I think I'm going to erase that and put it in different colors so you see which ones X is 2. Z is 3. Solve for y. Okay, solve for y. I have 3y equals negative 3. So y is equal to negative 1. Okay, this is a point, so let's please put it in alphabetical order. x is 2, y is a -1, and z is 3. And this is your solution. I know it's long, that's a lot of work, but please be patient with it. Okay, I'm going to go and do some more examples. Okay, so here's example 2. So the first step is to find two equations. I'm going to number these 1, 2, and 3. Okay, so you have to find two equations and eliminate a variable. So I'm going to pick 2 and 3, and I'm going to let's eliminate y. So -2x minus 5y minus 2z. This is equation 3. Equation 2 is -2x plus 5y plus 2z equals 4. So these are already opposite coefficients, so all I need to do now is just add. I'm going to add these together. I get -2 minus plus a -2 is a -4x. -5 plus a 5 is 0. -2 plus 2z is 0. And then 12 plus 4 is 16. It's okay that the other variable dropped out. It doesn't matter that if it does or not. Nothing says you can't. Just still solve. So we're going to still do the same process. So I'm going to divide by -4, and I get x equals -4. Now, second step tells me I need to use the unused equation and one of the other ones to actually solve and eliminate what I did before. So I'm going to still eliminate y. I still have to do this step. You don't, just because we got x equals 4, it doesn't matter. So what I'm going to do is I'm going to choose, I have not done number 1, so I will do this as step 2. Number 1, we have -4x minus 5y is 18. And then it doesn't matter which one I choose. I have to eliminate the y's, so I'm going to do equation 3. So I'm using equation 1 and 3, and I'm still eliminating a y. So I'm still doing that. So they are nice and already opposite of each other, if you see here. So now I got to do is add. So -4x minus 2x is a -6x. The 5 and -5 y's are 0. And then I have -z plus 2z, which is just a z. And then 18 plus 4 is 22. Now I'm going to go to step 3. Step 3. Okay. Remember, after you've done this 2, here's your system. You have this. Here's your new system. 2 variables. And then you have x equals -4. There's still equations. There's an equal sign, so it's okay. But now what we do is the next step, step 3 says solve the new variables, 2 variable system for both variables. Well, I already have one solved. So for step 3, I got to find the other one. So that means all I got to do, I already know what x is. I substitute x in for that first equation. Put a -4 there with the x, and I just solve for z. I already have x. Because step 3 says solve the new variable system for both variables. I already have one. I need the other one. So this is 24 plus z equals 22. Subtract 24 from both sides. You get z equals a -2. Okay, so now that's step 3. The last step, step 4, tells us that we need to substitute the 2 solutions from number 3 into one of the original equations that we started with. Okay. and we're going to solve for the third variable. So we have x and a y. So if x and z, if I put it in my point form, this is what it's telling me I should have. Now, let's find y. So it doesn't matter which equation you use. I'm going to use, so step 4, I'm going to use equation number 3, which is negative 2x plus 5y plus 2z equals 4. Right? So in place of the x and the z, I'm going to put what the value is. So x is a negative 4. Don't know what y is. Z is a negative 2. Now we solve. So it should be only one variable. So I have 8 plus 5y minus 4 equals 4. And then I have 5y plus 4 equals 4. Subtract 4 from both sides. I get 5y equals 0. Divide by 5. So 0 divided by 5 is 0. So this point is negative 4, 0, 2. Now this one was a little bit different. Only the difference was that this system right here, I got one of those. All right, let's go on to the next example. All right, we're on example 3. So the first thing we're going to do is we need to pick 2 equations. So again, I'm going to number my equations so that I know which one I want. Here's 1, 2, 3. All right, so these are my 3 equations. I'm going to pick 2 that I want to and eliminate a variable. I'm going to pick equation, let's do, I'm going to eliminate my z's. So I'm going to do 1 and 2, okay? So I'm going to eliminate z using equation 1 and equation 2. This is step 1, right? So now I want to limit my z's, so they have to be opposite coefficients. So if I look at that, I notice that this is this one right here is a negative 1z, but this is a positive 3z. So what I'll do with this one is I'll just multiply the top equation by a 3. So I'm just going to rewrite those 2 equations over here. Give myself some room to do some math. So let's multiply this top one by 3. I'm just going to move this down here. So I get 6x plus 9y minus 3z equals 15. And so I'm just going to go and add these 2 together. The ones I'm going to highlight. I'm going to add this with this. And my z's should be gone. So 6 plus 4 x's, I have 10 x's. 2 plus 9 is 11, so 11 y's. My z's should cancel. And negative 1 plus a 15 is a positive 14. Okay, that's step 1. Step 2, we are going to use the equation that we did not use. Okay, we're going to eliminate z again. I have to eliminate the same variable. And I'm going to use, let's see, I used 1 and 2, so I have to use 3. So I'm going to use 3, and I'm going to use 1 again. So I'm going to use 1 and 3. Okay, so I'm going to write them down here so I can see them. Okay, now I want to eliminate the z's, so I have to multiply this top equation by a 6. Because I want it to be the opposite of a positive 6. So I'm going to write this here. So 12x plus 18y minus 6z equals 30. So let's bring that second equation down. Well, actually, I can just add these two together here. So I'm going to add these two that I'm highlighting. Add this with this. So 3 plus 12x is a 15x. Negative 4 plus y plus 18y is a positive 14y. Positive z and negative 6z cancel out. And then this is negative 19 plus 30, which is an 11. Now, you've created a new system. Okay, you have this one here and this one here. So if I write this new system, I'm going to write it so I can see it. And this is for step 3. Because in step 3, we're going to solve the new system for both variables. So my new system is, for step 3, (10x plus 11y equals 14). And then I have 15x plus 14y equals 11. Now the thing about this one is that they're not that simple to, easy to see that I can make opposites of them, okay? When you do this part, if you can find the smallest number to do, because if you don't get to use a calculator, you might want to look at that. So if I look at the x's, if I decide to eliminate x's first, and you can do substitution first, but there's going to be a lot of fractions, so I highly recommend elimination. So when you look at these two right here, 10 and 15, I can multiply both of those to have a same number, and it's not very big. If I make them, they have a common, the least common multiple of those two is a 30. So if I want to make them 30s, okay, I have to make one an opposite. So in order to make this a 30, to make 10 become a 30, I have to multiply by a 3. I'm going to multiply it by a negative 3. In order to make 15 a 30, I just have to multiply it by a 2. Now again, I'm looking this way. So this is going to give me, my new equations are negative 30x minus, and I'm sorry, I should have stated, I'm eliminating the x's. I didn't say that already. So now 11, so I'd multiply that by a 3, and I get a negative 33y, and then 14 times negative 3 is a negative 42. And then when I multiply the bottom equation by 2, I get 30x plus 28y equals 22. It's kind of hard to see this, the right into it. So that should be a negative 33y, 28y, okay? To eliminate the x, now I gotta do is add. This goes away, they're opposites, so negative 33 plus 28y is a positive, it's a negative 5y, negative 42, and plus 22 is a negative 20. Divide by negative 5, and we have y equals a positive 4. Okay? So now that we've done that, we're going to take this y, choose into any one of these two that we have up here, and solve for the x. Okay? So I'm still in step 3. So I'll just move over here. So, okay. So now, over here, I'm going to take the top one. I'm going to take 10x plus 11y equals 14. And in place of y, I will put a 4. and solve for x. So we have 10x plus 44 equals 14. Subtract 44. We get 10x equals a negative 30. Divide by a 10. X equals negative 3. Okay, that was step 3. Last step. So step number 4. Okay, step 4 says to substitute those two values that we found in step number 3 into an original part of the equation. So I need to solve for z. So I'm going to use equation 1, which is 2x plus 3y minus z equals 5. Okay, I know x is a negative 3, and I know that y is 4. Minus z equals 5. 2 times a negative 3 is a negative 6. 3 times 4 is 12. Minus z equals 5. This is 6 minus z equals 5. Subtract the 6. Negative z equals negative 1. And then so z divided by negative 1. Z equals 1. So now your solution is a point. So don't forget, it's negative 3, 4, 1.